The National Electrical Code, often referred to as the NEC, is a comprehensive set of standards developed to ensure the safe installation of electrical wiring and equipment. It's a critical document for anyone involved in the electrical industry, including electricians, contractors, inspectors, and engineers. Its primary goal is to protect people and property from hazards arising from the use of electricity. The NEC is not a law itself, but it is widely adopted by states and municipalities, becoming law through local ordinances and regulations. It's important to understand that the NEC is updated every 3 years, so staying current with the latest edition is essential for compliance and safety. The NEC covers a wide range of electrical topics, including wiring methods, overcurrent protection, grounding, equipment installation, and special occupancies. It provides detailed requirements for conductors, cables, raceways, enclosures, and other electrical components. The code also addresses specific types of equipment, such as transformers, motors, generators, and appliances. One of the key concepts in the NEC is overcurrent protection. Overcurrent devices, such as circuit breakers and fuses, are designed to protect electrical circuits from excessive current, which can cause overheating and fires. The NEC specifies the appropriate size and type of overcurrent protection for different circuits and equipment. Another important aspect of the NEC is grounding. Grounding provides a low impedance path for fault current to return to the source, which helps to trip overcurrent devices and prevent electrical shock. The NEC outlines the requirements for grounding electrodes, grounding conductors, and bonding. The NEC also addresses wiring methods, which are the ways in which electrical conductors are installed. Common wiring methods include rigid metal conduit, electrical metallic tubing, non-metallic conduit, and cable assemblies. The NEC specifies the types of wiring methods that are permitted in different locations and applications. In addition to general requirements, the NEC also includes specific rules for special occupancies, such as hazardous locations, healthcare facilities, and swimming pools. These occupancies have unique electrical hazards that require special attention. For example, hazardous locations, such as those where flammable materials are present, require explosion-proof equipment and wiring method. Healthcare facilities require special grounding and bonding to prevent electrical shock to patients. Swimming pools require ground fault circuit interrupters, or GFCIs, to protect against electrical shock hazards. The NEC is organized into chapters, articles, and sections. Each chapter covers a broad topic, such as wiring methods or equipment. Articles provide more specific requirements within a chapter, and sections provide detailed rules for specific situations. The NEC also includes tables and examples to help users understand and apply the code. To effectively use the NEC, it's important to understand its structure and organization. Start by identifying the chapter that covers the topic you're interested in. Then, review the articles and sections within that chapter to find the specific requirements that apply to your situation. Use the tables and examples to help you understand and apply the code. It's also important to consult with qualified electrical professionals, such as electricians or engineers, if you have any questions or need assistance interpreting the NEC. The NEC is a complex document, and it's easy to make mistakes if you're not familiar with its requirements. The NEC is based on fundamental electrical principles and safety practices. It reflects the accumulated knowledge and experience of electrical experts from around the country. The code is constantly evolving as new technologies and materials are developed. The NEC is not intended to be a substitute for good engineering judgment. It's a minimum standard that should be supplemented by sound electrical design practices. It's important to consider the specific needs of each installation and to use your professional judgment to ensure that the electrical system is safe and reliable. The NEC is a valuable resource for anyone involved in the electrical industry. By understanding and applying its requirements, you can help to ensure the safety of people and property. The NEC is a living document that is constantly being updated to reflect new technologies and best practices. It's important to stay current with the latest edition of the NEC and to participate in the code-making process. The NEC is developed by the National Fire Protection Association, or NFPA, a non-profit organization that develops codes and standards for fire safety. The NEC is updated every 3 years through a consensus-based process that involves input from a wide range of stakeholders, including electrical professionals, manufacturers, and regulators. The NEC is divided into 9 chapters. Chapter 1 covers general requirements such as scope, definitions, and rules of installation. Chapter 2 covers wiring and protection, including overcurrent protection, grounding, and wiring methods. Chapter 3 covers wiring methods and materials, including conduit, cable, and raceways. Chapter 4 covers equipment for general use, including appliances, lighting, and motors. Chapter 5 covers special occupancies, including hazardous locations, healthcare facilities, and swimming pools. Chapter 6 covers special equipment, including electric signs, elevators, and data processing equipment. Chapter 7 covers special conditions, including emergency systems, fire alarm systems, and communications systems. Chapter 8 covers communications systems, including telephone, radio, and television. Chapter 9 contains tables and examples to help users understand and apply the code. The NEC uses a numbering system to identify each section of the code. The numbering system is based on the chapter, article, and section. For example, Section 210.12 covers arc fault circuit interrupter protection for dwelling units. The number 210 indicates that this section is in Chapter 2, Article 210. The number 12 indicates that this is the 12th section in that article. The NEC also uses abbreviations and acronyms to refer to common electrical terms and equipment. For example, AWG stands for American Wire Gauge, a standard for measuring the diameter of electrical conductors. GFCI stands for Ground Fault Circuit Interrupter, a device that protects against electrical shock. The NEC is available in several formats, including print, electronic, and online. The online version of the NEC is updated regularly and includes interactive features, such as search and bookmarking. The NEC is a complex and comprehensive document, but it is essential for anyone involved in the electrical industry. By understanding and applying its requirements, you can help to ensure the safety of people and property. Firstly, always consult the latest edition of the NEC. Secondly, understand the code's organization and numbering system. Thirdly, use the tables and examples to help you understand and apply the code. Fourthly, consult with qualified electrical professionals if you have any questions or need assistance. Fifthly, participate in the code-making process to help improve the NEC. The NEC is not just a set of rules, it's a framework for creating safe and reliable electrical systems. It's based on sound engineering principles and years of experience. By following the NEC, you can help to prevent electrical fires, shocks, and other hazards. The NEC is a valuable tool for protecting people and property. It's an investment in safety and reliability. Remember, electrical safety is everyone's responsibility. By understanding and applying the NEC, you can help to create a safer world.